Okay, so everyone, we're gonna go ahead and get started. Welcome to the first of our two introduction days for SICSS West Central Africa. We'll be covering the schedule and program. We'll introduce myself, PPiA, Hugue as well, and then we will also talk about the itinerary, the projects that we'll be doing within the program, and then we will also talk about or watch the introductory videos for the entire program, and then also for what computational social science is. And SICSS stands for the Summer Institute in Computational Social Science. So just to introduce myself, I graduated from a school in the US and I studied global health and development studies for my undergraduate degree. I'm a current PhD student at the University of California, Berkeley. I'm studying sociology and data science, and my research focus is on nutrition, health, and then also development in Cameroon and the broader African context. I've interned before for the Carter Center and the Cato Institute, which are both organizations. The Carter Center focuses on health and neglected tropical diseases in the developing world, and then the Cato Institute is a think tank that focuses on libertarian and free thought, like just freedom in general. I'm a current intern with the UNDP at the Human Development Reporting Office. I haven't really received any major assignments for that yet, but I'll update you on like what kind of things I do for that. And I'm very passionate about improving education and employment and entrepreneurial outcomes in Cameroon and the broader Africa.
Do you want me to carry on, Ben?
Yes. Oh, and then I'll also introduce, PPiA. Yes.
Oh, okay. Public Policy in Africa Initiative is a Cameroon-based think tank. You know, we do research, we publish articles in French and English. You know, we focus specifically on Africans' problem, you know, and we also have a leadership academy where we teach people about emotional intelligence and leadership. We also teach on our leadership academy public policy analysis. We have our flagship program, which is the Coding Academy, where we teach young Africans how to code. You know, our next batch of students studying how to code will start in July. The program is a 6-month program, 3-month theory and 3-month practice. So we select 40 people around all Africa. This time we selected 40 people in 11 African countries. So we teach them online how to code. So we do so for free. It's our flagship program. A lot of people apply. We receive sometimes average 120 applications per session. And we are very proud of this program because of the way it has impacted people. So if you want to learn how to code using Python and develop application, you know, you can still apply. The next application will open around November of this year to start in January. We also give our researcher at the Institute freedom to write on whatever they want to, like I said earlier on, provided it's related to Africa, economy, society, or environment. Thanks, Ben. Like I mentioned before, our key area of research include health, agriculture, governance, youth, employment, small and medium-sized enterprise, education, climate change, of course, and entrepreneurship. But if you come up with a good, you know, research like in COVID-19, we still accept it because it's relevant of today's economy. Next slide, please. So our core value at the Public Policy in Africa Initiative is liberty. We believe in freedom more than any other things without neglecting the others, meaning we're right intent. That each and every one of us should do the right thing. Quality too, our work should be of good quality, you know, and excellent. For example, when it comes to our publication, you cannot publish with us if your article or your op-ed or a report is not reviewed. And you cannot also publish with us if your article, report, or op-ed is not language edited. So we kind of put this, you know, to guarantee a minimum of quality. It's very important to us. So our mission at the PPiA is to promote evidence-informed policy, which is critical in Africa. We should move away from intuition and personal experience and more toward evidence-informed policies. We promote economic liberty, meaning we put this entrepreneur at the center of the economy, not the government. We wish entrepreneurs should be put at the center of the economy. The private sector should be put at the center of the economy and not the government. We also promote entrepreneurship, women empowerment, human rights, democracy, government integrity, effective and fair justice system that help countries in Africa prosper in free, fair, and sustainable economies. Our vision is powering the African economy. We believe that the African economy should take a new direction. Not the direction is taking now, which, high GDP growth that are jobless. We believe we should do something about it, but we should base our advice or policy prescription on evidence. Thanks, Ben. Next slide, please. Well, this is a little bit about me. I think this is available on our website for those of you who want to know more about me. Basically, I have a PhD in management, specifically finance or econometrics from the University of Bath. It's a PhD in finance, but the content of my PhD is more econometrics. Econometrics means the application of statistical method to economic data. I also have a master's degree from the University of Johannesburg in South Africa. I'm the founder and head of Public Policy in Africa Initiative. As you already know, currently I'm a consultant, economic consultant with ABIQ Business Intelligence based in Dubai. I'm also a political and economic commentator for BBC Africa, Africa Vanguard, and Equinox TV. Maybe some of you have saw me on TV, on Equinox TV or Equinox Soir Research and Leoto. I specifically covered Cameroon, where there is a BBC Africa, Equinox Soir, Africa Vanguard, sometimes another country. I also taught as a teaching assistant at the University of Bath in the UK, financial market, and also corporate finance and investment appraisal. This is a little bit about me. I'm also involved in a startup right now with a friend of mine, co-founded a startup. I will talk more about it during our training, in-person training. Thanks, Ben. Next slide, please. Oh, that's you now.
Yes, thank you. So hopefully you got a good introduction to the both of us and then who PPiA is. We'll talk about the broader SICSS program and how that plays into the identity of PPiA a little bit later. But just to go over some basic things with the itinerary. So the first 2 days is going to be week 1, and that's going to be our welcome, introduction, ethics, and then tomorrow we'll have a discussion just in general about using computational social science data, et cetera, and trying to use that to understand where Africa is going, where Africa has been, and then talk about how much our voice has been put into things and what things would look like if we incorporated our voice more into those discussions. So today and tomorrow will be on Zoom, and then starting on Monday, we'll have 2 weeks that's in person. It'll be at Java Space and Amubla IPN in Bonaprizo. The dates are June 13th to the 24th, only on the weekdays. The timing will be from 7:30 a.m. to 12 noon, and then food and refreshments will be served at the end of at 12 noon. And so we've talked about week 1, but week 2 will be the methods, data, and basic R training. And the SICSS program provides programming for us to learn a few skills, but I didn't think that it was appropriate in terms of the amount of different things that are out there. And so you'll get exposure to all the different wide varieties of computational social science and data science methods that you can use to look at data and get outcomes. Week 3 will focus exclusively on working on projects. So there's a few proposed projects. We can also create some, and then we'll spend the entire week coming up with the justification for the projects, working on finding the data for the projects, and then also analyzing the data, and then doing a recorded presentation. Afterwards, the SICSS program actually provides a lot of funding for people to continue projects. So if people are interested in the projects that we've built so far, then we'll be able to continue them and have funding for that throughout the rest of the year. So one of the proposed projects is exploring African countries' borders with modern computational tools. So I've kind of compiled a few questions here to kind of get at some of the things we should think about and why I think this project could be useful. I've actually workshopped the idea with other Cameroonians, people who work for development organizations, professors, and so far they think it's a good idea. So we can talk a little bit about it now. But the first question is when, how, and under what justification were African borders drawn? I think most people know that the borders were drawn under a context where Europeans were dividing the countries, the people, to figure out who's going to get the most spoils of war. And that kind of provides thought for us as to how, whether or not we should continue with current borders, should we rethink borders, what effect do the borders have on us today? That's kind of captured in the second question. What are the economic, political, social, cultural, and other consequences of contemporary borders? When the borders are drawn in the ways in which they were in the past, that leads to a lot of things. For example, the way in which you structure infrastructure to come throughout the countries and facilitate economic development. It decides how many countries there are. It decides how many people are put into a specific political context, how well people are able to deal with former colonial powers, how well people are able to deal with each other amongst the different African countries. There's social and cultural consequences, and then there's many others. And so the idea is to think of, is there a better way to draw the borders compared to what they are today? And what factors are most important for nation formation? So if we go through the thought process of, let's say, for example, that people were to say, should we go through and redraw these African country borders? Should we have countries that merge together? Should we break some countries up? What factors are most important for that? Is it ethnic group? Is it language? Is it geography? Is it the kind of crops they grow? Is it any other kind of factor? And then also, what new methods exist today to make this process easier? Or at least, can there be some kind of empirical justification behind creating countries? And so when we think about this particular project, one way in which we could do it is we could take data points at the city level or the village or town level, and we can create attributes for those different towns, cities, et cetera. And so if we figure out that we believe that ethnic group is important in nation formation, or if we believe that geography and terrain is important for nation formation, because you want to have a country that's relatively easy to deal with environmental policy, for example, than having a country where you have 5 or 6 different types of climates. How can we think about doing a project like that? So that's one proposed project we have for the program. Project 2 is thinking about the future trajectories of global migration. So the first question to think about with this is, what is the best destination for migration? Many people from African countries migrate to places in Europe, or they migrate to places in the US or Canada, but sometimes there are attractive options in places like the Middle East or in Southeast Asia and India that may change the dynamic of where the best places for migration could be for people who are migrating for certain reasons. We want to figure out where people are migrating to and where people are migrating from. So even though right now there's a lot of people migrating from places in Africa or Southeast Asia or Latin America, will it always be the same people migrating out to other places? And will people be changing the places they migrate to as well? Then we want to think about what are the main reasons for migration and how these are going to change over time. So, for example, if African economies start doing better, you may have a smaller outflux of migration for reasons of employment, for example, but you may have an increase in migration for reasons of climate. And so that's another factor to think about. Push-pull factors driving migration is the same as the reasons for migration, but thinking about it in terms of how can we delineate them into factors that are variables we can operationalize. Are any of these factors linked with demonstrated imminent change? So there's global trends right now with things like climate change, economic growth, how well countries are developing in terms of infrastructure, education, health, et cetera. And so these are going to help us think about where global migration is going to go in the future. And is it possible for us to chart a path for what migration will look like in the future? And is this different than what's in the normal discourse today? And so I think coming from this perspective, many people from African countries want to migrate, but many people from African countries' voice is not really put into the literature to kind of understand what things are going to look like in the future and how they'll change. So this is the second potential project that we will explore in the program. And then the third project is looking at the long-term population effects of COVID-19. So a question we should think about is what population mitigation strategies were used because of COVID-19. We saw things like lockdowns, we saw things like curfew, mask wearing, and then what effects did this have on the micro and macro levels of population life? So if you have a large proportion of the population that's unemployed, or like 40% because of the COVID-19 mitigation strategies, or if you have a large proportion of population who couldn't go to school, they didn't have access to internet, those are some of the effects you'll see at the population level. And when we think about what long-term effects will it have on populations, even if it's small per person, if you delay the education that 10 million children, for example, have in the Central African region, that's going to have a small effect on each individual person. But when you multiply that across an entire population, that leads to pretty sizable economic impacts or education impacts. And so we want to try to quantify those large impacts based on small population, small changes within each individual unit of the population, and then figure out which mitigation strategies should be used to kind of deal with those effects before they become bigger in the future. And so before we move on, does anybody have any questions about either of us two organizers, PPiA, or the itinerary or the projects we'll be working on in general? And you can either comment or you can raise your hand or you can just unmute and speak.
Hello.
Hello.
Hi, I'm Boris Jamin.
Hi, thank you. It's nice to meet you.
Nice to meet you too. I have a small question. What is the final goal of these projects? Are we looking for paper publication? Are we looking, what is the final goal? Just to understand.
Yes, the final goal of the projects is definitely to get publications, and I think high impact publication. So far, there haven't been any research studies that seriously deal with what African country borders should look like, for example. And so there's many people who write papers on this is how the African country borders are written. These are maybe the effects of what the African country borders look like. But there's no discussion as to, for example, whether or not countries should shift borders, should change borders, whether or not countries should merge. We do have things like ECOWAS or the East African Community of States, but those deal with broader alliances of countries and not necessarily whether or not countries should rethink their approach as to who's a citizen of where and things like that. So that project was thought of as a very high impact project if we can do it correctly. And it will give us a chance to work on the skills that we learn in this particular program. And then it also gives a chance for people from Cameroon and people from Africa in general to contribute a lot to the conversation as to what's going on. The same thing for the Global Migration Project. I think that there's a lot of trends going on underneath the scenes that point towards global migration changing compared to what people think it is today. And so I think people generally see countries much more static than they really are. And what that means is that I think people don't see ways in which Western countries are becoming unattractive options. I don't think people see the ways in which African countries are becoming more attractive to stay in, work in, and progress in. And I don't think that people are also seeing opportunities come up as quickly as they are in places like Kuala Lumpur, Singapore, and other places in Southeast Asia or even the Middle East. And so I think that we could be, as a research unit, one of the first people to kind of predict the future of global migration that's more realistic, but drastically different than what's in the literature. And so that could be another high impact paper as well. And the final project is looking at the long-term effects of COVID-19. Right now, people are kind of in the mindset of, depending on where you are in the world, I think there's maybe less of a focus in places like Latin America or Africa or Southeast Asia. I don't think that people think about COVID as much and as, I guess, in a limited way than compared to they do here in the Western world. And so right now, people are still trying to deal with the economic impact today of what COVID is, but we could also be one of the first research units to talk about what the effects of COVID-19 will look like in 10, 20, or even 30 years. So hopefully that brings clarity. So yes, we're looking for not just publications, but high impact publications that are published in big journals that seriously have a big effect on how we think about a lot of these things in the world. Does that answer your question?
Yes, thanks.
Yes, thank you. And so if anybody has any questions, please don't hesitate to reach out. We have 2 videos. The first video here will be about what computational social science is, and then the second video will be about the SICSS program. So the SICSS program is a series of these different locations where we learn about computational social science, and they provide a lot of online programming, which we will use. But then we're also going to offer a lot of our own bespoke programming through PPiA. And so the idea is that they give us funding through, so as PPiA, we can host this program, we can come and train students, we can do projects, we can write papers, etc. And so we're supplementing some of their programming with our own. There's a lot of methods they didn't cover that are really important, like regression, discontinuity, the longitudinal and time varying kind of methods, clustering, all kinds. And so hopefully you'll get exposure to all the different methods out there, and then we'll explore those methods in the projects, which will give you hands-on experience. Now, we'll go ahead and watch these 2 videos, and then we'll have some time for questions and comments after this session. And then we'll talk a little bit about what we'll do next session, and then that's it for today. So again, if anybody has any questions, comments, or they need clarification, just comment in the chat or raise your hand and we can pause the video and then address them. So thank you. Can everyone hear the video?
Yes, I can, Ben.
Hello. In this video, I'll be providing an introduction to computational social science. So one of the questions I'm asked frequently is, what is computational social science? And since I'm asked this question so much, I thought about it and I came up with the following definition. Computational social science is anything that's cool. Now, of course, this is kind of a joke, but it's also kind of serious. That is, I really think as a field, as computational social scientists, we should try to resist the urge to define what the field is at this moment. And I think that for 2 reasons. First, the field is changing really quickly. So I've been in conversations about computational social science for a long time. And let's say 10 years ago, I was in conversations about how we should try to define the field. And if we had tried to come up with a definition 10 years ago, that definition would almost certainly not be the right definition for today. Right, so in a field that's changing really quickly, I think we should resist the urge to try to build boundaries around the field. The second reason why I think we should try to resist a formal definition, at least for now, is that we can think of computational social science as also as a kind of social movement. It's people who are trying to change the way certain kinds of research takes place. And so for social movements, it's very helpful to have a big, open, welcoming tent that everyone can participate in. So for example, the organic food movement in the United States in the 70s, that was really initially made up of people who had very different goals. So some of those people wanted food that tasted better. Some of those people wanted to support local family farms. Some of those people were really worried about whether the food didn't have pesticides. So all of those people worked together to create the organic food movement. And it was only after that movement had grown substantially that they sat down and figured out a set of rules that were necessary in order for a food to have an organic sticker on it. So by being open to the contributions of many people, they helped the field grow. And so for those two reasons, I think it's best not to have a formal definition of computational social science. However, we still come back to the question, what is computational social science? And anything that's cool is maybe not the most helpful answer. So what I'd like to do instead is give you an example of a study that I think illustrates many of the important themes that, that come up over and over and over again in computational social science. So this is a study by Josh Blumenstock and colleagues that was published in Science in 2015. And let me tell you a little bit about the problem they were trying to solve. So global efforts to end poverty run into many, many, many problems. One of those problems is that it's actually hard to know how much poverty there is, where it is, and how it's changing over time. So for many people in wealthy countries, we're used to having national statistical systems that collect these kind of data in a regular and ongoing way and at high quality. However, in many of the world's poorest countries, exactly where this information is most needed, it's often not available. And so what Blumenstock and colleagues were interested in was seeing if they could come up with better ways of measuring the amount of poverty and wealth in developing countries by using mobile phone metadata. And so let me tell you a little bit more about how their study worked. So they started with a bunch of call records. These are records from the calls of 1.5 million customers of Rwanda's largest mobile phone provider. So they have records of outgoing calls, incoming calls. They have the location where the call took place, the cell tower. They also, so they don't have the actual, what was said in the call, but they have the call metadata. So this call, the call records, they provide a lot of information about these 1.5 million customers, but they don't provide exactly a measure of poverty and wealth. And so what the researchers did is they took a random sample of these people and actually called them and gave them a survey, a traditional social science survey that's designed to measure poverty in developing countries. And then what they did is they linked up these two very different kinds of data to use them together. So first they took the call records and they went through a process called feature engineering, where they converted these records where there is one row for each call into something where there's one row for each person and one column for each feature. So features, these columns could also be called variables, but I'm going to use the word feature. So they have a feature could be something like number of outgoing calls or number of incoming calls. But it could also be more complicated things like, of the people that you call, what percentage of them call each other? Things like this could all be features. So then once they have a big matrix where one row is each person, one column is each feature, they can build a machine learning model to link these two things together. So they trained the model to, given the features they have about your calling behavior, to try to predict what you would say on this survey about your poverty and wealth. Then once they've built that model, they can use it to impute the survey responses for all the other customers. So by giving a survey to about 1,000 people and combining it with the call records, we're able to then impute or guess the survey answers for the other 1.499 million people. Then they also were able to infer everyone's residential location. And so the way they did this is roughly by looking at where they made their phone calls at night. So what they did is a little bit more complicated, but that's the main idea. And so you can put this now together with these estimated levels of wealth and estimated residential location to produce high resolution maps of poverty. So this map here, the red square with the tiles, that's a 1 kilometer by 1 kilometer square. And you can see within that, they're able to produce estimates of extremely small geographic areas. In this graph, darker areas are wealthier. And so you may be thinking, wow, how accurate are those estimates? And the answer is, we don't know. So in fact, no one has ever estimated poverty at that small of a geographic scale before in Rwanda. So it's actually very hard to know if these estimates are good or not. And this is a problem we see actually frequently in computational social science, where we're estimating something that's actually never been estimated before. And so it's hard to know how well this new technique is working. But fortunately, Blumenstock and his colleagues were working at a setting where they did have something else that they could compare to. They were able to compare to the Demographic and Health Survey, which is a large-scale probability-based sample with in-person interviews that's funded by the US government. These are done all over the developing world. And these are considered gold standard data about health and demographic information in developing countries. So to be clear, these are not perfect, but this is a very good estimate, one of the best estimates we can feasibly make. So let's see how this new technique compared to this existing gold standard technique. So Blumenstock and colleagues aggregated their estimates to produce one estimate for each of the 30 regions in Rwanda. And these are the estimates that they produced. Now, here are the estimates that come from the Demographic and Health Survey. Now, as you can see, these two maps look quite similar. So for our purposes, I'm going to say they're basically the same. Now, in the paper, of course, they do a very detailed comparison. But for our purposes, we can say these two things are basically the same. So now you may be thinking, wow, it looks like Blumenstock and colleagues figured out a way to make estimates for something that we already knew how to do. Like, we can already do the Demographic and Health Survey. Why do we need this new approach? So what I haven't told you yet is the approach by Blumenstock and colleagues is 10 times faster and 50 times cheaper. Now, 50 times cheaper, it's not 10% cheaper, it's not 20% cheaper, it's 50 times cheaper. This is qualitatively different. So for example, right now, we do demographic and health surveys roughly 1 every 5 years. If we could cut the cost by a factor of 50, we could do these surveys every month. And so we wouldn't have to wait 5 years to collect this important information about these countries. We could collect it every month, much like it's collected every month in many wealthy countries. And so this is another thing that comes up a lot in computational social science, where often the advantages of new techniques are that they are faster and cheaper. And so sometimes it's very important to then but often researchers are not really excited by faster and cheaper. So taking these improvements in speed and cost and then mapping them back to a scale that researchers are more excited about, something like going from demographic and health surveys every 5 years to every month. And so also the researcher in me wants to be clear that this is not totally a fair apples to apples comparison. That is, I said the approach by Blumenstock et al. Is 10 times faster and 50 times cheaper. However, the approach from the Demographic and Health Survey has formal theoretical guarantees that come from the nature of the probability sampling. And there's substantial know-how that's gone into deploying these surveys all over the world. So there's a lot of practical know-how that we've learned over the last 50 years for how to do these effectively. And the approach by Blumenstock and colleagues doesn't have any of that. It doesn't have this 50 years of know-how, and it doesn't have formal theoretical guarantees yet. And yet is the key word. So learning from these big data sources is one of the fastest growing areas that I see in computational social science. And I think eventually we will start to solve many of these problems. So let's take a step back from the Blumenstock et al. Study and think a little bit more about what is computational social science. So the Blumenstock et al. Study combines things that are computational. So for example, taking the call records and converting that into that feature matrix where you have 1 row for each person, 1 column for each feature, building that machine learning model. There are a number of complex computational steps involved there. It also involves social science in terms of figuring out what is an important research question to ask. How do we collect the data on poverty? How do we then make estimates that are meaningful to policymakers? So it's a blend of computational and social science. This study also involves ethical and privacy questions that are now considered complex. So in this particular case, they had access to the metadata of the call records for 1.5 million customers of this mobile phone company. And so to be clear, they did not have the calls, but they had access to the metadata. And in other research, we've learned that the metadata from call records is actually quite identifying. So even though they didn't have the names and addresses of these people, it probably would have been possible to try to figure out who these people were and learn things about them. Now, to be clear, Blumenstock and his colleagues didn't do it, but they had to be very, very careful because of the privacy risk that the data had. Finally, this study combines two different types of data in a way that comes up a lot in computational social science. So it combines data that are ready-made and custom-made. And so let me illustrate these two styles of data with an example from art history. So this is a urinal, but it's not just any urinal. This is a very special urinal. This is Fountain by Duchamp. This is one of my favorite pieces of art. It's so creative. So what Duchamp did is he saw this urinal and he said, this is not a urinal, this is art. This is a process of repurposing, taking something that was created for one purpose and turning it into something different. And I think often some of the best data science research in the field of computational social science involves this creative repurposing. So for example, Blumenstock and colleagues, the call records, those were not created for the purposes of research. Those were created for helping to run a phone company. And Blumenstock and colleagues said, no, I can take those records and repurpose them for something else. And so this repurposing is very is practiced very well in the most creative and beautiful data science research in computational social science. And so if we had to come up with another style of art to illustrate the type of data that's more common in social science, it would be perhaps David by Michelangelo. So when Michelangelo wanted to create David, he didn't look around for something that kind of sort of looked like David. He said, I'm going to labor in this marble for 3 years to create David. And so that is an example of a custom-made piece of art. And so we have this example of ready-made, which is more illustrative of the style of data scientists. And we have this example of custom-mades, which is more illustrative of the style of social scientists. And I think what we will see increasingly in computational social science is the idea of combining these two styles, just as Blumenstock and his colleagues did. The call data, the call records alone were not enough, and the survey data alone were not enough. It was only by combining them that they can make these high resolution estimates of poverty. And I think increasingly we will see that each of these pure approaches will run into limits. The pure ready-made approach, I think people who are accustomed to using ready-mades will realize that there really aren't that many fountains out there. There's a lot of urinals. In other words, there are real limits to what we can learn by repurposing data that was never created for research. Likewise, for researchers who are more accustomed to working with custom-made data, it will become increasingly difficult to ignore all of the ready-made data that exists in the world. If our goal is to learn about the social world as quickly and accurately as possible, then it becomes harder and harder to ignore all the ready-made data that exists and now try to imagine all the ready-made data that will exist 5 years from now and 10 years from now. So even if that data doesn't have the precise measurement properties that we want, even if it's not collected in the way that we're used to, we can't simply ignore it. If we want to learn as much as we can, we're going to have to figure out how to take advantage of these ready-made data sources. So I think increasingly, just like in the study we saw from Blumenstock, we'll see combinations of ready-made and custom-made data. So what is computational social science? I think it often has these three characteristics. It involves a computational element and a social science element. It often involves ethical and privacy questions that are now considered complex. And it often combines ready-made and custom-made data. So now that I've said what computational social science is, I'll tell you another question that I get asked frequently, which is, isn't computational social science just a fad? And here I have a much simpler answer, and the answer is no. So let me tell you why I don't think computational social science is a fad. It's not a fad because it's being driven by a fundamental change in the world. And what you can see here, this graph shows the amount of information stored in the world. And there's two patterns that you should take away from this graph. First, the amount of information in the world is expanding very quickly. And second, more and more of this information is now stored digitally. And so it is this transition from the analog age to the digital age that is the fundamental driver of a lot of the opportunities in computational social science. Now, this graph shows the trend from 1986 to 2007, but information storage follows exponential growth similar to Moore's law, where things double every 2 years. And so there's similar Moore's law type behavior in our ability to store and transmit data. And so this graph here goes up to 2007, but from 2007 to 2009, the amount of data has doubled. From 2009 to 2011, the amount of data has doubled. 11 to 13 is another doubling. 13 to 15 is another doubling. 15 to 17 is another doubling. 17 to 19 is another doubling. And this kind of doubling will proceed for the foreseeable future. And so as social scientists, we have the opportunity to take advantage of all of this, or we can be left behind. Now, when people think about all this information, they often tend to gravitate towards thinking about online sources. They think about social media data, search data, things like that. But increasingly, we should think about this as digital data is created everywhere. So one of the trends in computing now is the so-called Internet of Things. So maybe you have an Alexa device in your house. That's an example of a sensor built in the physical world. And increasingly, we're seeing more and more of these sensors built in the physical world. So just as now, all your behavior at an online store is instrumented and they have the ability to run experiments on you, it will increasingly be the case that in the physical world, our behavior will all automatically be recorded, and the physical world will be instrumented to enable more experimentation. And so when you think about all of this data that's created in the digital age, don't just think about online, think about everywhere. So I don't think computational social science is a fad, but I do think it has fad-like elements. And so the way I like to think about this process of fads within the field is this graph here, which is called the hype cycle. So this was created by Gartner Consulting. And so the x-axis here is time, the y-axis is visibility. Initially, there's a technology trigger, and then we move to this peak of inflated expectations. So this is where people say, oh, big data is going to change the way we learn about the world, and it's going to end poverty and cure cancer and end unrequited love. And then people start to realize, actually, well, there's a lot of problems with these new data sources. Some of these capabilities don't work as well as we thought. And then they move into this trough of despair. But then over time, we figure out how to solve some of these problems. And then we move into the plateau of productivity. And so one way that I think our goal as a field should be is to push down this peak of inflated expectations, pull up the trough of despair, and get to the plateau of productivity as quickly as possible. So what will that plateau of productivity look like? So as a sociologist, I can think of two things in my own field. So first is computational social science and digital techniques. They do not displace other techniques, they complement them. So think about a doctor and an X-ray machine. So just because a doctor has an X-ray machine doesn't mean that she wouldn't talk to her patients. That would be a crazy doctor, right? So it's something that complements the other tools that we have. It doesn't replace them. And second is computational social science doesn't change our goals. So our goals as researchers are the same as they were before, to understand the social world. Computational social science just helps us achieve those goals more quickly. Again, a doctor with an X-ray machine. The X-ray machine does not change the doctor's goals. Her goals are still to help us get better. This is just another tool that she has to help her achieve those goals. So that's a little bit about what I think the plateau of productivity will look like. Now, how do we create a computational social science community? Imagine you're about to take part in a community that brings together people to help learn about computational social science, something like the Summer Institutes in Computational Social Science. So I think the key idea is data scientists and social scientists working together, with each group realizing that they have something to learn, and with each group realizing they have something to contribute. So now you may be wondering, well, what is a data scientist? Just as I talked before about what is computational social science, you may wonder, what is a data scientist? What is data science? And again, I think the answer is anything that's cool. So Again, I have a more serious answer. What is data science? I think this paper is excellent for answering that question, 50 Years of Data Science by David Donahoe. I strongly recommend this paper if you haven't read it. So he traces data scientists not to defines it not to be people with laptops and hoodies, but he traces it to go back to people like John Tukey, who were focused on learning from data. And so that includes statistics. It includes certain parts of computer science, it includes certain parts of other engineering fields. It also includes certain parts of social science, and it includes certain parts of things that aren't currently happening inside of universities. So data science, I think, is really about learning from data, and it includes statistics and much, much more. So the idea of social scientists and data scientists learning from each other and also teaching each other is a great way that that computational social science, the community can grow. But this kind of exchange will not be always so easy. But we have to remember first that data science alone is not enough if we want to study social behavior. If the questions are fundamentally social in nature, then ideas from social science will be key in defining what the important and interesting questions are and helping answer those questions. Likewise, social science alone is not enough if we want to be able to take advantage of these new digital age data sources. So it's really only going to be through a coming together of these communities that computational social science will thrive. However, the coming together of these communities also creates some challenges. And so Hannah Wallach, who is a computational social scientist, reports hearing this kind of conversation. I don't get it. Why is that research? And so what you might find as you start engaging with people who come from different disciplinary backgrounds, that there is this mismatch in what people expect and what people think is good or important, interesting research. So Hannah Wallach divides people into these two broad communities, computer science community and social science community, and roughly summarizes the kinds of characteristics of research in these fields. So computer scientists can study almost anything. The work is largely methods driven. It often uses large found data sets, and the focus is often on prediction. Social science, on the other hand, often studies social things. It's often question driven, where those questions come out of a long research tradition. It often uses small design data, and it focuses on explanation. And so if you find yourself in a community that mixes together social scientists and data scientists, or even social scientists from within different fields, you're going to have this experience of misunderstanding or not quite understanding what other people are doing, why they're doing what they're doing. And so again, the key thing to keep in mind here is that each community has something to give to the other, and each community has something to learn from the other. And so if you find yourself having more of a background in computer science and you're talking to a social scientist, try to understand more how they see the world and why they're doing the research that they're doing. Likewise, if you're a social scientist and you see a computer scientist that's doing something you don't quite understand, again, try to see the world through their perspective and try to understand how their discipline approaches research. It's through a combination of these styles that we'll be able to do the most interesting research going forward. Another difference that you'll see if you start engaging more in a computational social science community like the Summer Institutes in Computational Social Science is that there are a little bit different emphasis between the fields. So let's look at this picture here. Is this glass half empty or is this glass half full? And if I had given this as a test question to a bunch of social scientists and data scientists, I think we would see a difference in their responses based on their training. So I've noticed that when evaluating and thinking about computational social science research, data scientists are often more glass half full. They look at the things about the study that's exciting and they focus on those. Social scientists, on the other hand, are generally more glass half empty. They look at a piece of research and they find the parts of it that they don't like and they emphasize those without paying as much attention to the things that are cool about it. And so I think increasingly a healthy computational social science will focus on the fact that this glass is really both half full and half empty. And so if you find yourself being more of a glass half full person and you engage more with a glass half empty person, try to look at the world from their perspective. Likewise, if you're more of a glass half empty person and you try to take the glass half full approach for a while. And only by being able to switch back and forth between these views will we be able to make as much progress as we can in computational social science? So I think the future of creating a computational social science community will involve blending insights from social scientists and data scientists. That's not always easy. When people from different backgrounds interact, it can be difficult, but that interaction is really where a lot of learning happens. And that interaction can often, the friction from that interaction can often be a spark for really exciting and interesting research. Thank you.
Okay. Hi, everybody. So that was the video about the intro to computational social science. So hopefully it captured a lot of the elements as to what it really is, where the data comes from, how people can create data, and we'll also discuss that more in depth with examples next week when we talk about specific methods. But if you have any questions, please, again, don't hesitate to reach out, and you can just unmute and ask them, or you can put them in the chat. There are 3 questions so far from Steve, and so I'll answer each one of them. So the first question is, who is authorized to run a computational social science project? And so I'll give a kind of complicated answer for that. And so technically anyone can work on a computational social science project, even if you don't even have a college degree. As long as you have the skills, you can go work on a project. You can even submit it for publication if you want, or you can do a startup that uses the same kind of models that are in these methods. Now, when it comes to some of the complications behind that, that's when you can run into trouble. So for example, here in the United States, if you want to get data that you would use in a computational social science project, many times they'll require you to be what's called a principal investigator. And to be one of those, you have to have a PhD. And so there's some situations in which you may want to get data from a place like the World Bank or the UN or any kind of large international organization. And if it has anything to do with the West, or it's especially headquartered in America, you may run into problems like that. In terms of publishing in journals, you can submit publication even if you don't have a degree or anything like that. But of course, we know how biased those publications are. And so they may favor people who have a degree over those who don't. They may even favor people based on the school they went to, et cetera. And so really honestly, anybody can work on these projects. And so if you can't get data from those big organizations that may require you have a PhD, you can mine data, for example, from places like Google or Twitter, which there's programming in the SICSS that we'll talk about next week. And then we'll also go through how to get some of that free data. But yes, anybody can work on these projects, but there's some complications as to how you work on it and how easy it is to get the data. Project 2 is, how are we going to collect data for our projects? So that's a little bit complicated. We're going to have to first decide whether or not people are interested in the projects that we have, or whether we should change the projects, and then 2, figure out which models that we want to use. And so for the project about exploring African countries' borders, that may be a particular project where we ourselves have to actually create the data. And so there's not necessarily a ready-made data set for that. And it may not even be easy to find the data points that we need. But what I imagine we would do is work at the city level or the town or village level, and we would have to create or think about which variables we can justify being the most important for nation building. And then we would go find that information online in the most standardized way possible. So for example, if we're looking at just, let's say, the capitals of the 54 African countries, you may want to say something like GDP is important, or GDP per capita is important, or you may want to say like ethnic or regional group is important. So you could use a standardized data set like the World Bank. You could also use a standardized data set like Wikipedia and Wikipedia pages sources. And what you would do is, you wouldn't necessarily have to download anything from the World Bank website, but we would just create an Excel sheet of the 54 countries that we're dealing with, or the number of cities we're dealing with. And then we manually take the data and then go plug it in the data set, or we can create a function that will do it for us quickly. So hopefully that answers that question. And then for the other projects, there's ready-made data sets online. For example, in global migration, the World Bank will have data as to where people are migrating, what economies are looking like in different countries, how fast education opportunities are coming up in different countries. And that's kind of the data we'll use. We'll just put it into our own data set again. And then third is, are there any competencies required to run such projects? As long as you understand how the data works and you understand the methods that we're going to cover next week, anyone should be able to run these projects. We might have what people perceive as a very surface level approach towards learning the methods, because it would be impossible to go very in depth, for example, to understand like the statistics behind everything, and then also be able to do everything in R incomplete. But we're really just going to focus on the methods we'll use for our project. And then in future iterations of this program, we will cover more specifics, or we can even upload programming to YouTube. But in general, we will be able to conduct the projects that we will be working on in this particular program. And so anyone can run such projects. And there was one more question: will you make it possible to attend the entire training also virtually? Yes, we will find a way to make it hybrid, and then we'll also try to record all of the sessions to make sure that everyone can participate. So hopefully that answers the questions that we've had so far. Does anybody else have any more? There's a question asking whether the remote sensing can also be considered as a computational social science. What do you mean by remote sensing? Could you unmute and explain really quick? Is it pronounced Severin? Hello?
Hello. Hello.
How are you?
Hello.
Hi.
Hello, are you getting me?
Yes. Can you hear me?
Okay. Thank you. I have a small question about the computational social science. I want to know that if the remote sensing is can be considered as a one domain of computational science, because a remote sensing is the science that in which we collect some data as a map shapefile in the web, Google Map, and so on, and use it in some software as QGIS, ArcGIS, and so on and so on. So to collect some data about territorial border and so on. I want to know, because if we use remote sensing to collect data on the population, for example, we use remote sensing to collect data on the map, on the land use, on the land cover of some territorial. That is why I'm asking my question.
Okay, yes, thank you. So we
Hello.
Hello, can you hear me?
Hello.
Hello? Can you hear me? Yes, so we can use geographic data. There's a specific type of software that we use called GIS, or a specific type of approach or method. And GIS essentially stands
Yes.
Geographic Information System.
Yes.
So that geographic information system allows us to take maps, and we can break the maps down into different elements and levels. So for example, you could take a map of, let's say, Cameroon, and you could take things like rivers or mountains or tree coverage, and you can add those as elements into this GIS map, and you can use that or combine it with other data to run models and different things. I'm not particularly skilled with GIS, so we would need to consult someone outside to incorporate that, but it is a particular method that people use for sure, and it does fall within the computational social science and data science methods. So hopefully that answers the question. But yes, the general answer is yes. And then there's one more question that says, for example, how can I develop my skills on CSS having no basis? So one of the best ways to, throughout this computational social science program, throughout this training that we're doing through PPiA, we're going to cover most, if not all, of the major methods that people use. So we're going to cover things like regression, clustering, classification, tree-based models, deep learning, neural nets, longitudinal data, regression discontinuity, and we're even going to cover approaches dealing with data, for example, mining data, feature engineering, et cetera. And so the best way to develop skills on this is, once we're moving throughout this program, to take the basics that we learn here and then build on a specific model that you like to use the best, or to go even back and learn a little bit about the statistics and things like that. So if you haven't covered things like statistics, probability, then also learn a little bit about the underlying mechanisms of the model. So it doesn't really make sense for us to cover things like, for example, what OLS, or ordinary least squares regression, means, because that's not something that really affects us actually doing the project. But going and learning those things can make your skills become better, because once you understand the models a little bit better, you can understand innovative ways to use data. You can even come up with new models. You can figure out better combinations for models, how to make your model better. Because when we create these models for these computational social science or data science projects, you're going to get some kind of way to measure the effectiveness of it. So let's say, for example, you're doing a model that's trying to predict some outcome. You're going to have your prediction, and then you're going to have like the percent correct that your prediction was, or the likelihood that your prediction is fully correct, how well it does on the testing data is what we call it, et cetera. And so that's the ways in which you can improve on CSS skills. And so you don't need to go to university. Many trainings and things are offered online for free. At the university that I'm studying at, we actually watch videos from YouTube to learn the material, and we do projects throughout the class to work on it. So as long as you're working on projects or you're watching more videos to learn about these methods, then you can get a much better, you can get better training, if that makes sense. And so hopefully that answers all the questions, and thank you for the comment. We'll go ahead and watch one more video, which is just explaining what the SICSS program is, and then we'll be done for today. And then we'll have some time for questions or discussion, but we'll pretty much be done for today after this video.
Hey everybody, now that you've had a chance to learn a little bit about what computational social science is, I want to tell you a little bit about why we started SICSS, the Summer Institutes in Computational Social Science. The first and most important reason is that we face a lot of challenges, both as a field of researchers and also as a society. In other words, there's a lot of big problems in the world that we're dealing with right now that require the tools of computational social science to solve them. A pretty obvious example right now is the COVID-19 pandemic. More than ever, we're seeing the need to track human behavior on a massive scale, using social media data, using advertising data, using Google search data, to try to make sense not only about things like the spread of the disease itself, but also whether measures that have been put in place, such as social distancing directives, have been impactful. Like Duncan Watts likes to say, maybe this is the moment where social science has finally found its telescope. We can ask questions about things like the spread of disease or how to prevent disease with unprecedented detail and acumen. So that's a huge opportunity, but it's also a huge challenge. The second big challenge that we face as a field, as computational social scientists, is that our field is growing so rapidly. Here's some data that I pulled together with some graduate students of mine and a postdoc who I worked with that looks at data from the Web of Science. The Web of Science, in case you don't know, is a really large repository of scholarly work. So journal articles in a lot of different fields, probably the biggest one we have access to. Now, it's not perfect. It leaves out important things like conference proceedings. It leaves out a lot of books, but it's probably the best way we can get a sense of where the field of computational social science is growing and in what disciplines. So as this graph shows, the big takeaway here is it's growing everywhere and fast. It's growing fastest in fields like psychology, business, and communications, sociology, political science, economics, and many, many other fields. If you want to learn a little bit more about how this data was put together, you can look at the link at the bottom of this slide or on your screen right now. A third challenge we face is we're not only growing fast, but we're growing in every direction. So we have people making huge advances in, say, political science that aren't being conveyed to people in, say, psychology, or vice versa. Now, if we plot the network where we connect every study in computational social science by a tie, if those studies are citing each other, we see something that looks like this. We see pretty good interdisciplinary conversation happening in the middle of this network. We see a lot of people who depend upon each other, but we also see some isolated fields, some disciplines that have not yet come into the fold. And I think all of us who practice computational social science would agree that we need each other more than ever. We can't just use machine learning to solve social science problems, and social science on its own can't ignore things like machine learning if we want to take on the biggest questions of our time, like how to fight back against COVID-19. So we need to learn how to grow fast, and we need to learn how to grow with each other. And we need to do this while we're solving some of the hardest problems that social scientists have ever been asked to solve. Another huge challenge that we recognized when we put together SICSS is that high quality training opportunities are really rare. So most often people might get skills from, say, a computer science class where they might learn great skills in computer science. You might become a fully fluent Java programmer, or you might learn a lot about systems architecture. The important question is, though, is that the most efficient way for a social scientist to learn? And conversely, can a computer science professor recognize the many challenges that a social scientist might face? Things like you're going to learn about throughout this program, like response bias, selection on the dependent variable, circular reasoning, right? The broader tendency for social scientists to care a lot about the difference between the data that we collect and the data that we don't collect, right? All of these things are central to social science. So what do we need? We need a space in between. We need those who don't have a lot of coding skills to learn some coding skills. And we also need those who have a lot of coding skills to learn a heck of a lot of social science. And that's what we're trying to do here. We're trying to provide a really unique training opportunity that brings together both people who can code like this and people for whom this code is a little bit intimidating. And we want to welcome everybody. I'll have some more to say about that in just a minute. So how do we get there? What's the most efficient way to solve big problems, to let the field grow rapidly, to let the field grow across many different fields, and to give everyone high quality training in precisely the type of stuff that they need? This is why we came up with SICSS. The idea is pretty simple. We provide high quality lectures. We provide an opportunity for promising young scholars to come together, interact with each other, build a community, and even, as I'll explain in a few minutes, do some really exciting research together. Though SICSS started out in 2017 as a relatively small conference of 30 people at Princeton, it's since grown into a massive worldwide enterprise. And we're really, really happy about that. So our first goal is to provide state-of-the-art training to teach you how to recognize code like this in this picture here, but also to give you the instinct, if you are perhaps someone who doesn't have much background in social science, to learn and understand the basics of human behavior so that you can better recognize how the rapidly expanding toolkit of STEM fields, science, technology, engineering, and mathematics, could be repurposed to study human behavior. So as I mentioned earlier, another core challenge we have is straddling disciplines. We've got to connect economists to sociologists. We've got to connect sociologists to data scientists. We've got to connect data scientists to public health people if we're going to solve challenges like COVID-19. So how do we do that? Here again, you see in this slide, both the opportunity for connection and the challenges of maintaining that connection. So rather than train just, say, one type of social scientist, rather than getting all the political scientists in one room and training them, or getting all the sociologists in one room and training them, we've learned that putting everybody in one place both optimizes the learning experience and also propels the field forward in terms of research. We get to hash out all those sticky, difficult, interdisciplinary conversations that we have to have, things like recognizing each other's jargon, learning how to talk to each other, but we're also going to learn a ton from each other. And that's the second goal here. We also want to do this because we know that atypical combinations of science actually lead to better science. This is the abstract pictured here of an article by Brian Uzi and colleagues that actually measured the impact of scholarly work by things like citations, media mentions, and so on. And what they found is that the more interdisciplinary teams are, the more impact they have. And we've certainly seen that and are starting to see that in the group projects that we are incubating here at SICSS. Third, we want to reach a really broad audience. A core challenge with any kind of computational field is people perceive it as hard or inaccessible, or they think they're just not good at coding. We want to provide an environment where virtually anyone can enter the field. That's easier said than done. We want to reach both computer scientists who have been and data scientists who have been coding in 3 or 4 languages for, say, 5 or 6 years and teach them about social science. We also want to take social scientists who have never been introduced to, say, an open source computing language and tell them what that's all about and explain to them why we think that's vital for their career. So we want to reach a really broad audience. Already we've done that. In 2018, we had about 8 partner sites in locations as diverse as Helsinki, South Africa, Chicago, New York. And in 2019, we're really proud to say that we expanded even further to Mexico City, to Istanbul, and some of those sites that I just mentioned, Cape Town, Chicago, repeated. So we're really starting to see the community grow, and we're really starting to reach a broader and broader audience. And what we're trying to do at SICSS is provide a core modular curriculum that you can take and repurpose to your audience. So if your audience is mostly data scientists who already know a lot about coding, our curriculum is designed to help you introduce them to social science. If, on the other hand, your audience is, say, mostly social workers who have very little exposure to coding and don't have a lot of, say, quantitative training in social sciences, we want to provide a curriculum that takes you from 0 to 60, from beginner to expert. And so we're really trying to reach a broad audience. This map here shows just how far we're expanding, either from 2018 to 2019 to this year to future years, where we expect to expand into East Asia, South America, Europe, and increasingly Africa. If you want to check out any of the material or the communities we've built from previous years, we invite you to check out the SICSS website in order to find links to all the participants, the organizers, and all the unique content that people in those particular places produced. We also started, or I should say, our students have started exciting new initiatives to help further diversify computational social science. If you have a minute, check out verycss.org. This is a really exciting new initiative started by Taylor Brown and Tina Lee to identify underrepresented groups in computational social science and give them a way of connecting to each other, creating community there, but also helping all of us senior scholars who are organizing conferences, who are, say, hiring folks, to really see the remarkable many different kinds of diversity that this field now has. And again, just like we think that scholarly diversity is going to lead to better science, we think that having diverse perspectives from people from many different countries, language areas, religions, ethnicities, class statuses is going to improve our field as well. Our fourth goal at SICSS is to be fully open source. We want to make everything available to anyone who wants it. The central vehicle from which we've done that is our website, which you can visit by Googling SICSS, the Summer Institutes in Computational Social Science. And there you'll find not only information like you might have seen already about how to get involved in a SICSS site, but also a permanent repository of online videos, code, annotated code examples, and other learning materials to help you either teach yourself or to use them or repurpose them from your own classes. This site, called Learning Materials, which is a part of our webpage, has all of these materials from past years, this year, and will soon have material from future years as well as a variety of bonus materials from leading figures in the field that we're really excited for you to check out. Finally, you can find all the materials that we use in our teaching curriculum, every slide, every picture, every image, every snippet of code on our GitHub site, which is linked at the bottom of this slide here. What this lets you do is see how we, for example, build presentations like the one I'm showing you right now. But it also lets you decide, hey, I really like this piece of content, but I really didn't like this other one. And I want to swap it out. I want to do my own thing. Again, SICSS is supposed to be modular. We not only provide you with some core curriculum, but the many people who have led SICSS sites all over the world are doing the same. And we've now got a rich curriculum across many different languages, different programming languages, different substantive foci that anybody can learn from, we hope. Finally, we want to put ourselves out of business. We want to teach you. We want to teach the teachers. Why do we want to do this? Because we think this is the fastest way to help computational social science grow. And we're really pleased to say that already in our first 2 years, we've trained some of the most exciting young leaders in the field who've already run their own SICSS partner sites, but who are also advancing into faculty positions, postdocs, and industry positions all across the world. And so we want you to know that as you're learning here, we'd love for you to pay it forward, to train someone else. That's how I learned. That's how we all learn. So let's teach the teachers. Finally, by virtue of this massive expansion across the world, we've created a really remarkably diverse community that you now have access to. If you follow the link below, you'll find a list of everyone who's ever participated in a SICSS site. Many of them have websites and other materials linked that you can check out to find potential research collaborators or to reach out for people for help or guidance. Because we've tried to incubate this mentality of paying it forward, we think you'll be surprised when you reach out. You may just get a wonderfully enthusiastic response from the great people that we try to bring together at SICSS each year. So finally, in this section of the videos, I just want to tell you a little bit about how SICSS works. First, our schedule will vary a little bit across sites, and across years, but more or less, we ask you to participate in lectures by Matt Selganek, myself, or other partner site leaders during the first week of the event. And during the second week of the event, we do research. And mixed in between there are a lot of group-based research exercises and also lectures by leading scholars in the field, top-notch people who inspired us and we hope will inspire you. Before we start the research process, we do something a little unique here at SICSS. we do something called research speed dating. We put everyone in a room after they've had about a week to learn material. For many people, this is very new material, and to work together in small groups and to meet some of these top leaders in the field. And then we put them in different small groups and ask them to come up with research ideas. First, we put them in groups where people are matched with similar interests, and they come up with one type of idea. Then we put people in groups that are extraordinarily and intentionally diverse. Then we see what type of research ideas they come up with. Then after each group has created a few rough research ideas, we put them all up on a board and people opt on to different research projects at different sites. Where we can, we support these efforts with small grants, which are rare for junior scholars, graduate students, postdocs, and junior faculty to realize to get their feet wet in the field of research. Our core curriculum covers about 6 issues. In these first sets of videos, you're getting an introduction to computational social science. And in the following videos, you're going to get an introduction to ethics, an enormously important subject, which really is crucial to the future of the field. You're going to learn about things like how digital research is recasting issues like informed consent or beneficence or other types of principles that we've used to guide human subjects research in the social sciences for years. And you're going to do interesting small group exercises where you discuss the ethical trade-offs of some of the most exciting or risky field experiments attempted to date. The second big picture topic is collecting digital trace data. And that really means collecting data from websites, archives, any kind of usually text-based data, though not always text-based data, that helps us study human behavior at scale. We'll learn about things like application programming interfaces, how to collect data from a site like Twitter. We'll learn about screen scraping, how to extract information from a website. Finally, we'll learn a little bit about building apps and bots for social science research, which is some of the frontier of the field that I'm really excited about and excited to teach you about. On the next day, you'll learn about automated text analysis, one of the hottest fields in computational social science. I'll give you a tour of basic text analysis, dictionary-based methods, unsupervised methods such as topic modeling and text networks, and we'll wrap up with some broader discussion of how these text measurement tools can be used to study human behavior. Our fourth big topic is surveys in the digital age. So just as survey response rates are plummeting, the opportunity to meet people where they are online is more potent than it ever has been. And so Matt Salganik is going to talk to you a lot about that, talk to you about non-probability sampling, talk to you about digital surveys in the digital age, and talk about both the opportunities and the challenges of that new type of research. The next subject is mass collaboration. You're going to learn from one of the best. Matt Salganik is going to talk to you about his exciting work on both wiki surveys, tools for collaboratively measuring public opinion amongst large groups of people, and also the Fragile Families Challenge, the first ever, to my knowledge, attempt to create a data science style competition around a social science problem like childhood poverty. Finally, we're going to teach you about experiments, and specifically the enormous opportunity to run field experiments, either in vivo experiments on online platforms, or create platforms where you yourself can control how people are interacting, really opening up a huge new array of questions to study human beings. To access all these materials, you simply need to go to the Learning Materials section of our website that's linked below. There you'll find not only all of the videos like you're watching now, but any slides, annotated code, and other learning or teaching materials that you need to follow along with each lecture. Also on that page, if you scroll down to the bottom, you'll see we have a section called Visiting Speakers, where you can see videos from the last 3 years by leading figures like here, Duncan Watts, or Deborah Estrin, or Sendhil Mullainathan, or David Lazar, Gary King, really wonderful top names in the field, and we'd love for you to check all those out. Lastly, I want to say a few things about our group projects. Though many of these are going to take the form of pretty modest proposals about research you might done. How much can you really do in 1 week? Well, the answer is quite a lot. Can you write a whole paper and can you publish it? No. Could you write an entire R project and get it online? Maybe not. But the idea is to crash this, to do it on the startup model, and to see how far you can get, to start the project, and to ensure or to encourage you to continue it afterwards. We provide small amounts of funding during the event with the possibility of larger amounts and helping you connect to other funders after the event. And already we're really proud to say that our research is appearing in top journals, such as the Proceedings of the National Academy of Sciences, as well as other kind of real contributions that might not be, say, academic outputs, but software or other open source tools, or the very CSS initiative that I told you about earlier to help diversify computational social science. Finally, if you're following along online, if you're not at one of our partner sites, here's a link for you to try to connect with other people who might want to participate in research who are also following along online. Let me close by saying a few words about our expectations for you. We've learned a lot about how this institute and how this whole event works best. Let me say a few words about that. First, and maybe this one's obvious, is we all need to be open. We all need to be open to different ways of understanding the world, different ways of measuring the world, different ways of communicating our findings, and different ethical beliefs. And openness is going to be a core pillar that we're going to build on throughout the event. So we ask you to kind of suspend some of your biases, your prejudices about other fields, and try to meet people and learn from them. Second is patience. It is really hard to design a curriculum that can both help students who have never coded before and those who have coded a lot, or those who have read, say, dozens of books in social sciences and those who have read none at all. What we've tried to do is strike a happy medium. Wherever possible, we try to provide resources to people who need to go deeper in the form of links, annotated code, or by staffing TA hours, teaching assistant hours online before our events. So please do take advantage of those. But if you find that the curriculum is moving too fast, please take time after to work through the exercises on your own, or better yet, in groups, or better yet, with the help of a teaching assistant or a SICSS alumni. If, on the other hand, if you're feeling like the content is going a little too slow, like you already know this, well, there's probably something for you to learn too. For example, maybe you can learn about how to best teach and communicate computational social science. Everybody, we think everybody has something to learn here. Togetherness, we're in this together. As I said at the beginning, we need each other to make this field work. We need each other to do the, by definition, interdisciplinary work that comprises computational social science. So let's stick together. Generosity, I mentioned earlier, our ethic here is to pay it forward whenever you can. If you've learned a lot here, we ask that you consider paying it forward, being generous to others. That's the way we're all going to learn, particularly as this field is growing so rapidly that anything we try to teach here might be out of date in a few years. So we need you to make these kind of videos. We need you to create your own curriculum, link back to our site, to help us make the best quality training materials for everyone. If you have feedback that you'd like us to hear, please visit this link and give us some comments. In the meantime, let's get started.
Okay, everyone. So those were the two videos that should hopefully give you an understanding of what computational social science or data science is, and then also what the SICSS program is and the aim is. I actually completed the program last year. I did the SICSS location, but it was in the US at Howard University in a company named Mathematica. And so I wanted to bring it to Cameroon, and I hope that it can make a big contribution. So does anyone have any final questions or comments or things you want to discuss before we go? Okay, So everyone is quiet. So thank you everyone for joining us for the introductory session, for the introductions, also the explanations and some clarification. If you have any questions about the itinerary or anything else about the program, don't hesitate to email one of us and we can answer your questions or put it in the WhatsApp chat. And so we're finished for today. So we will begin tomorrow at the same time. That session will be about the same timing as this one, and then we'll begin in person on Monday. And I look forward to meeting everyone in person, and I hope everyone has a good night.
Thank you, Ben. Thank you very much.
Oh, there is one question real quick. What will be our contribution to the project? So we will decide on which projects that people want to participate in sometime tomorrow or on Monday. Then we'll kind of work through the projects and break them down into different pieces to figure out what kind of models we're going to use in each product and how we're going to get the data. That will be next Friday when we make up the specifics, and then we'll assign people different roles. And I'll be here as the teaching assistant to pretty much help people work through their roles and be able to run the models, to be able to get the data, and to be able to do all the things they need in order to complete the projects. And we don't actually necessarily have to finish the projects within the program. We can just make significant headway on the projects, or even get an introduction to the projects, and then we'll receive funding later on to continue those projects throughout the rest of the year. So hopefully that answers the question.
Sorry, Ben, Felicitas was asking if she can get some of those links that was in the videos. Is it possible to share it on the WhatsApp group?
Oh yes, I will share all of the links to the videos in the WhatsApp group. They'll all be housed on the SICSS.io website, at least the ones that we watched here. And then we're going to record all the sessions and then try to add them to YouTube and hopefully build our own platform soon.
All right, thank you.
Okay, so thank you everyone for joining today. I will see you all tomorrow.